Hello people, welcome back. The question is from GATE 2006 exam. It's for 1 mark and the topic is IP header. Question is, what is the purpose of TTL field in an IP header? So IP header contains a field called TTL and TTL stands for time to live. Okay. TTL is actually a number that indicates how many hops are allowed for a specific packet. For example, if TTL for some packet is 3, this means that starting from the source to destination, it can take maximum of 3 hops. Okay, if 4 hops are required, at the third hop only, this packet will be discarded. Okay, now what is the purpose of including such a field? It is to avoid infinite loops. Option C. Yeah. Now let me explain how does this field avoids infinite loops. First of all, let us see how can a packet fall into an infinite loop. Suppose there is some router. Okay. And there is an incoming packet on this router. What will this router do of that packet? Router will first analyze the destination IP address of that packet. Then it will see to which interface that packet must be forwarded. Okay. Suppose this router does not know where it must be forwarded. That means router cannot just decide on which interface or to which network should the incoming packet be forwarded. In such a scenario, router will ask its default router to take care of that packet. For example, this is router A. For every router, there is some default router. Okay. For router A, suppose default router is router B. So that incoming packet is given to router B because A does not know what to do. Suppose similar thing happens with router B also. B also does not know what to do. So B will forward it to its default router, which may be router C. Okay. Similarly, suppose router C's default router is router D. And again, router D's default router is router A. Now, this router did not know what to do. It has forwarded the packet here. Similarly, this one has forwarded the packet here. Suppose C also did not know what to do. It will forward the packet to D. And in case if D does not know what to do, that means D is not able to just decide on which interface should that packet be forwarded. In that case, D is going to give the packet to A. Now packet has fallen in an infinite loop. That means packet will keep on looping between these 4 routers only. Now what is happening? Routers are actually forwarding packets. Okay. Routers processing power is being used. The link is being used. But efficiently we are doing nothing because the packet is looping between these 4 routers only. Okay. And if this source, the source that actually created that packet, if it creates 100 more such packets, so now there are 100 such packets, we can say that entire capacity of these routers will be used in just creating a loop of 100 packets. So that is not very efficient use of this network, routers, links, bandwidth and processing power. Okay, so we want to avoid such a scenario. That is the reason we include this field called TTL. Suppose this source knows that a maximum of around 10 hops, the destination must be reached. That means source knows that destination is approximately 10 hops away from this point. Okay. It will just create a packet and say TTL is equal to 11. Okay. Or 10 maybe. Now, when this router will just receive that packet, suppose there was one more router in between, and say when this packet was created, TTL was set to 11. When this router receives that packet, it will see TTL is equal to 11. Now this router, what will it do? It will reduce the TTL. Every intermediate router is going to reduce the TTL. This router will reduce it to 10. What will this do? It will receive TTL is equal to 10. It will reduce it to 9. Okay. So this one has reduced to 9. Then 8, 7, 6, 5, 4, 3, 2, 1. Now when this packet will be forwarded, router B is going to receive TTL is equal to 1. Then before forwarding, it will decrement the TTL as each one of these routers did. Now this will be decremented to 0 and this router will just discard this packet because now it cannot take any more hops. All the 11 hops are completed. Okay. So this is how we can avoid infinite loops. So answer is option C. Now option A and B are just there to confuse you guys. They are saying to ensure packets reach the destination within that time. They are using this word time because full form of TTL contains the word time. Time to live. Even though it is called time to live, but it has nothing to do with time. TTL is not a time, it is actually a number, the maximum number of hops a packet can take. So similarly, option B also is discussing something about time, so this one is also wrong. Option D is to limit the time. This one is also wrong. Okay, so only option C is correct. Now let me explain one more thing. Suppose this is the sender and this is the receiver. And suppose TTL is equal to 3. This sender will not reduce the TTL because already it is the sender. Okay, why would it reduce the TTL? It will set the TTL to some value and send the packet. So sender will send the packet without reducing the TTL. Here the TTL received will be 3. Okay. This one is an intermediate node. It will actually reduce the TTL before forwarding. So TTL will be reduced to 2. Okay. Then this one will receive the TTL as 2. It will reduce it to 1. Then this one will receive the TTL is equal to 1. Is this receiver going to reduce it? No, because receiver will not forward it. TTL is reduced just before forwarding. Receiver does not want to forward it anywhere. Receiver's IP layer will realize that the packet was for this node only. Okay, so it will not forward, hence TTL will not be reduced. And anyways, this is the place where we actually intended to send that packet. So we need not worry about TTL because the packet has already reached the destination. Okay, so we have already seen that answer is option C, but now let me discuss how a router decides what to do with the packet. If there is an incoming packet, router will first analyze its destination IP address. And router has something called a routing table. Now in that routing table, we have 3 entries: the network ID, subnet mask, and the interface. For every interface, we will have such an entry. Okay, so interface A, interface B, interface C. And the network IDs of those specific networks will be written here along with the subnet masks. Now, what will this router do of an incoming packet? It will take its destination IP address and AND with these subnet masks. Okay. If the result matches with the network IDs, then to whichever network ID it matches, suppose it matches with this, router will forward that packet to interface B. Okay. But in case any of these network IDs does not match with the AND of IP address, comma the subnet mask, then there is always a default router. Okay. Router D or interface D. Then we are going to forward the packet to this router. Okay. Because this router can never be connected to each and every network in the world. Okay. It could be connected to maximum of 3 networks if it has 4 interfaces. Okay. And one more scenario where infinite loops can be created is due to some error. Okay. Say there is some error in this routing table or something goes wrong and these routers just keep on looping the packets. Okay, it might not be due to the fact that all of these are default routers of each other. There could be many other reasons, like there is something wrong with this router. It forwards every packet to this one only. Okay, or all other links are broken or not working. Something might go wrong and a loop might be created. So TTL avoids all such scenarios. Okay.